Hello students, welcome to our series, and that's the question of sequence in series in our ongoing series. That's the question which you all would have tried and you would have got it today, you would have tried. See, I consider it to be a good question of series involving like here that inverse trigonometric function also. Though we have solved one or two questions, but they were different. I consider it to be this one to be a bit different. So see, first term, the first step to solve a question of series is to write the general term. Okay, so that's one thing which I always say, we can't afford to escape. So I will write it as, so let's say the series is capital S, and moreover I'll be converting it to tan inverse using that tan inverse of x is cot inverse of 1 by x if x is positive. So cot inverse of 2 can be written as tan inverse of half, since all the numbers here are positive. So tan inverse of 1 by 8, which is 2q, plus tan inverse of 1 by 32, which is 2 raised power 5, and so on till infinity. So if I go for the general term, what can I write? So summation of tan inverse of 1 by 2 raised to the power, the powers in denominator 1, 3, 5, that form a simple AP, okay, with a common difference of 2. So if you write as R term, so it will be 2R minus 1, isn't that bacho? Where R start with 1 and of course go till infinity. Now what? So the key here is, see, we have already solved two questions, question tan inverse and sine inverse. Okay, so the key here is to rewrite the general term as the difference of two terms, and in tan inverse we are going for the formula tan inverse A minus tan inverse B, which is tan inverse of A minus B upon 1 plus AB. Okay, so according to me the key is 1 plus AB. So R is equal to 1 to infinity. But see, if I add 1 here, I have to subtract 1 there. Okay, so but will we get an identity? I can't see identity here. So what I will suggest here is, before going for that formula, and I mean to compare it with that formula A minus B upon 1 plus AB, I will like to multiply and divide by 2 within inverse function to get 2 upon 2 raised to the power R. Why? Okay, so that you can understand in the next step. So therefore S is this is summation when R goes from 1 to infinity. Now add 1, because to apply that formula I need 1 plus A into B. Now since you added 1, you have to subtract, and see, that's what I was saying. Now you have 2 raised power 2R minus 1, so I can look at it as A square minus B square. So A plus B into A minus B. If the power would have been odd here, 2R minus 1. So can I take it as A square minus B square? Answer was no. Okay. So just to apply that identity, I multiplied the numerator and denominator by 2 within tan inverse. Okay, so I forgot to write tan inverse, just a minute. Yeah, so what will I say? What will I write? I will write it as tan inverse of 2 upon, as I said, applying A square minus B square identity. So it's 2 raised power R A minus B and 2 raised power R plus 1 A plus B bachon. Okay? Now I am looking it as X, it as Y. Okay, so I will be writing numerator as its difference, and we will get 2 there. Okay, so the larger one, 2 raised power R plus 1 minus 2 raised power R minus 1. So when you simplify, you get 2, which you have in numerator. Okay, now we are done. Now we are done, bachon. 2 raised power R plus 1. So now hence we could break our series as difference of two terms. And what are those two terms? Tan inverse of 2 raised to the power R plus 1 minus tan inverse of 2 raised to the power R minus 1. Now let's start with R is equal to 1. So open it. So summation R goes from 1 to infinity. So let's start. So you put, rather I'm going to put the value itself. So I don't need, neither I need summation. Okay, and then put R is equal to 1. The first thing we get here is tan inverse of 3 minus tan inverse of 1. Okay, plus when we put R is equal to 2, so tan inverse of 5, 2 square plus 1 minus tan inverse of 3. Now see, we have already seen so many questions here. If you are left with one term in the beginning, then you will be left with exactly one term at the last with opposite sign. Okay, so since we are left with tan inverse of 1 with negative sign in the beginning, so we'll be left with last term with positive sign, and then as r goes to infinity, the last term will be tan inverse of infinity itself. So what we have finally is tan inverse of infinity minus tan inverse of 1. Tan inverse of infinity is nothing but pi by 2, and this is nothing but pi by 4. So the answer is pi by 4 here. Okay, so as I said, we have already done 2 such questions, so that's for practice, so that you are now, you know how to break or how to solve such series. So the simple thought process is that you have to rewrite the general term as the difference of 2 consecutive terms here, bachcho.